let's have a look at a maths tip of the day. So we're going to look at completing the square method. We've got x squared plus 6x plus 5, and this can be expressed in the form of x plus a all to be squared plus b. So that's in the completing the square. Right. I have highlighted that 6, the coefficient of x, for one reason. Okay, let's have a look. How do we do this? Step 1, half the coefficient of x, which is 6, and we get 3, and then we're going to now square it. Square. 3 squared, of course, equals 9, right? We're going to highlight this 3 because this is, we're going to come back to that in a sec. Step 2. So we're going to add 9 and take away 9. Curious. X squared plus 6x plus 9 minus 9 plus 5, right? So we've added 9 and take away. Of course, if you add those together, you end up with your original function. So what's the point of this? Well, in actual fact, the point of this, if I highlight this guy, right, this is a perfect square, and it's a perfect square, and I'm going to write down the factors of this perfect square. Okay, it is actually x plus 3 all to be squared. Okay, now I'm going to highlight this guy. All right, and I still have my minus 9 plus 5. So I've got x plus 3 all to be squared minus 4. Woohoo! I'm in the form I wanted to be in. So, but what we need to be careful is when we half that coefficient, we get the 3, and then we square it and we add it on and we take it away. But that 3 actually becomes the perfect square. So whatever number you end up with in the highlighted in green in the first place, that's going to be in the brackets, the x plus 3 ought to be squared. Okay, that should help you. Check out, we've got some Easter revision courses by topic online. Take it easy.